All right, so now we're going to extend the 2 by 2 matrix to a 3 by 3 matrix. And it says, by definition, the definition of the determinant of a 3 by 3 matrix is a third order determinant, which just means a 3 by 3 matrix, is defined by this. So they have rows and columns, so A1, B1, C1, A2, B2, C2, A3, B3, C3, and so on. Now it says each A on the right comes from the first column. So A1, A2, and A3. Now what you're going to notice is the first one's positive, regardless of what that saying says here. Second one you subtract. Third one you add. So positive or whatever, add, subtract, add. Okay. So that's going to work all the time. This will be positive minus positive. The signs for A1, A2, A3 do affect it, and I'll show you how in a sec. Now the next thing is, notice each one of these 2 by 2 matrices that's made is completely different. They're not all the same. B2, C2, B3, C3, B1, C1, B3, C3. See, those are not the same letters with the same subscript. B1, C1, B2, C2. So what I did was I brought this little chart here so we could see how each little determinant was made, or every 2 by 2 matrix was made. So it all depends on the positioning of A. So my first one, A1. You'll notice that A1 is in the first row, first column. So if we were to block off the first row and first column, so the first column, first row, what's left is B2, C2, B3, C3. So when you cross those out, you're left with B2, C2, B3, C3. That's how they got that there. And then you subtract, so minus H sub 2. Then you notice this is in the second row, first column. So they crossed out the second row, first column, leaving me with B1, C1, B3, C3. And then you add the next one. And here it's in the first row, or sorry, first column, third row. So we cross out the first column, third row, leaves me with B1, C1, B2, C2. So you see that's how they get the 2 by 2 matrices. And from here, they would find the determinant of this, multiply it to A1, find the determinant of this, multiply it to minus A sub 2, find the determinant of this, multiply to A sub 3, add those three numbers up, and that would be the determinant of the 3 by 3 matrix. So let's take a look at an example of this. All right, so first off, we have, let's start with our A. So this is our column right here. So this is A1, A sub 2, A sub 3. So we have a positive 4. Let's move this up a little bit. So we have a positive 4. And the position of that is in the first row and the first column. So once I block those numbers off, you'll see what's left is 3, 4, 8, 1. So I can see right there it is 3, 4, 8, 1. So I'm going to write these down. 3, 4, 8, 1. Now it says to subtract, and this is negative 9, so minus 9. And for this one, it's in the second row, first column. So the numbers that I see are left are going to be 1, 0 and 8, 1. So we can see 1, 0, 8, 1. So 1, 0, 8, 1. Then we add, the next one's a minus 3. And we do the same thing. This one is in the first row, sorry, first column, third row, which leaves me with 1, 0, 3, 4. All right, before I go any further, I'm going to just simplify this. This is a positive 4 with this 2 by 2 matrix, 3, 4, 8, 1. Negative and negative becomes positive. 1, 0, 8, 1. And a positive times a negative 3 is negative 3. 1, 0, 3, 4. Now, you should recall how to find the determinant of a 2 by 2 matrix. Review your notes if you need to. So I'm going to keep this 4 here, and I'm just going to work it out. So the way you find the determinant of a 2 by 2 matrix, if you forgot already, is you multiply the diagonals and you subtract it. So you start with here, the top left. 3 times 1 is 3, minus 8 times 4, which is 32, plus 9. 1 times 1 is 1, minus 8 times 0, which is 0, minus 3. 1 times 4 is 4, minus 3 times 0 is 0. All right, from here, I'm going to say 4 times 3 minus 32 is negative 29, plus 9 times 1 is 9, minus 3 times 4 minus 0 is 4. So 4 minus 29, or 4 times negative 29 is negative 116, plus 9 minus 12. When we work all that out, we come out to negative 119. So the determinant of this 3 by 3 matrix is negative 119.